Hello everyone. Last week we were looking at structured output. This week we are going to shift. This week we are going to look at memory. How does the chat, when we chat with ChatGPT, how does it remember? How can we make the applications remember our conversations so that it helps to make better decisions, decide better, right? Let's go over the examples. First, I'll show you the examples, then we can look into the code. So if you look at the prompt, let's see if it remembers. Let's go and do I am, let's say, Paul, right? And then I will send this request. So it says, hello Paul, it's nice to meet you, how can I assist you, and all those things, right? So let's go again, ask if it remembers. What is my name? So it says your name is Paul, is there anything? So basically it remembered, right? Let me go. This is one approach. There's problem with this approach. Let me show you what is it. Let me go and then do I am Saul. So it says hello Saul, it's nice to meet you, and all those things. So let me ask, what is my name? Now it says Saul. So if you had chatted with the chat GPT, right? If I go and tell my name and ask what my name was, it would tell me my name. And if you had asked about you, it would tell your name. The way we have set up now, it remembers, but it does not remember all the conversations, right? It does not remember different persons. It just remembers the last thing we were looking at. So there's flaw in this design. I'll show you in the code later. How can we make this independent of the user or customer or whoever is coming to the chat and then chatting with the system, right? So let me show you that. So I have that with the ChatMemory. So here it's basically same approach. What you are doing is you are sending the ID. It helps you differentiate between the users and it remembers. So let's go, I am Jesus. Jesus, right? And then give it user ID 1. Go Peter again. Nice to meet you, Peter, right? And then let's go I am Matthew, right? And then make it user ID 2. Okay, so it says hello Matthew. Now let me ask, what is my name, right? And go this way. So I'm sending the user ID and then the question. So it says, based on our previous interaction, your name is Matthew. So it remembered. Now let me change this to 1. It's saying your name is Peter. Now, did you see the difference? The difference is the ID we are sending. So that's what ChatGPT does. When we have different users, so it stores our ID, our username. Based on that, it differentiates. So it differentiates different conversations. So this is how the AI applications or LLMs can remember you, or it can keep you in the memory. So let me walk you through the code to see how we have done this. So this is code. Let's see what are the changes we made. So in the controller, basically not much change. I just changed the endpoints, right? Nothing, no logic, nothing changed. In the service class, also not much change. So there's two services, get memory, get chat memory, chat response. So this is without the ID, and then we had to differentiate the user. So for that, what we are doing is sending it over the advisor and then sending the conversation ID. So chat memory remembers conversation ID is a key, and then we are sending the user ID as a conversation ID. It remembers different users. This is how we are differentiating the users. That's only the difference. So in the config, there's not much difference. So this is just adding the memory, the simple logger that we already have looked into, right? That's all. We need to add the advisors and then add the chat memory to it. So message chat memory, we'll look into different one later. This is already implemented. So if you go inside this one, so you can implement this way. So it's storing all those things, how it is storing and stuff like that, right? You can look at the implementations of it. Pretty easy. So the reason I put the logger is like to see in the logger, if we see, so every time it makes requests, it sends everything, your previous messages and conversations. So that's something to look into. We'll look into a message window, which we need to look into and know about token, the memory or basically the size. There's context window, it can only hold up to certain information. There's size defined based on the model, right? So basically this is pretty easy in terms of code. I'll push this code, so don't worry about it. So okay, now this is like, this is okay, it remembers, but the way we have set up at the moment is if we restart the application, it just forgets everything, because this is in memory. This is in the in memory. This is stored in the in memory. That's why if you go look into how it's storing the messages in the form of map, and it's just storing in the memory, in memory, right? So every time the application restarts, nothing is going to be there. So for that, we have, I'm using JDBC S2 database, right, for now. So the changes we have to do is simple connection, DB connection, and then so for this to be connected with AI chat memory, since we are using the one that is not existent, the one they have already written, we are writing S2. They don't have S2 implementation, so we had to do, okay, initialize this and get the SQL from here, and this is the SQL. Otherwise this is already there. There are certain implementations like Cassandra and all those things which we don't need to write if you want to use that, but since we are using H2 to store this one, we have to do certain changes, basically configuration, and then this AI configuration chat stuff. We need to have this one, which you can just copy from the existing ones, and then in the config we have to tell don't use the pre-configured chat memory, tell it to use the one we created, JDBC chat memory repository, right? So if I restart this, okay, so it's restarted. If I go here, you can look at this one. Let's try to restart this one, and then okay, so if I do this one, run this one, there's okay, there's see, look at this one. I was trying this, so it has the chat we did earlier. So this is for persistency, right? Even if we kill the app and then come back, we need to have the conversation persisted. That's why we use this one. So if we go back to code here, I have set it to be 10. The maximum message it can hold is 10, because we have memory constraint, right? We cannot keep everything in the memory. It will blow out of context, the token size, it costs, all those things. So we don't, and also every request it's sending all of those things, so it remembers, and when it goes out of context, you start getting errors. So you need to be careful designing this so that it does not go beyond the capacity. So 10 messages. If I go to this one, so if I 1 2 3 4 5 6 7 8 9 10, and there's like different users. So if you go more than that, then you start losing, you'll replace the data. Then you always have 10 data, 1 2 3 4 5 6 7 8 9 10. So basically that's all the memory stuff. Try it out. So basically there's in memory, there's chat window to understand about, right? There's in memory message chat database data memory, and then there's a message window. Then after that you have persistent data. So I use JDBC H2. You can use Cassandra and all other kinds of JDBC stuff. So if let me show, I can show if there are, so this is in memory and JDBC they have implemented. So this is how it does. Look at this one. It puts it in the store, it puts it in the list, and that's how it remembers, right? Let me see JDBC. So this is what it is saying. Okay, this, it needs to be there, and it goes to that place and stores. There's all kind of CRUD operations already done for us, right? So basically this is easy, right? I mean, there's not much to understand too. It's the okay, there's, if I want to set up the memory, I need to configure it so it uses the memory. There are a couple of types of memory we can use: in memory, or window context, or some persistent DB like H2 or Postgres, or all other kinds of databases where we want to store the conversation. We can go and store in the vector database, which we will look into later. So that's all for today. Bye.